Okay, hello everyone. Okay, so today we will discuss the SEM 3KK, okay, your coursework for Math C. Okay, so this time around you see only one page, not like last time we got few pages. Okay, ask you to do many things, but the instruction are not that simple. You need to do many things, many calculations, but no, it's not going to be difficult. So at least now you need to prepare something to do together lah. So of course you will write in your papers, but you will need Excel also. Okay, so please prepare your laptop along. Okay, make sure your laptop can open Excel. Okay. Okay, now we will start. So this assignment is about it's about approximation. Okay, so in your syllabus, you learn how to use normal to approximate binomial. So normally I will write like this: from binomial binomial to normal. Okay, binomial to normal means this one is the actual one. This one is used to approximate one. Okay, this one is the approximation. So we use normal to approximate binomial. So in this case, in this coursework, we are going to see how to use Poisson to approximate binomial and how to use normal to approximate Poisson. Okay, so these two. As you can see in your task 1 and task 2. Okay, so I'm not sure today I'm going can have this or not, but if cannot, then there will be a second video. Okay, so let's look at task 1. So you can read the things. Approximation of a distribution to another distribution provide an easier and faster way to calculating the probabilities. To obtain closer estimate of the probability through the approximated distribution, it depends on a certain conditions. Okay, so we are going to identify the condition in your last conclusion. So you do the whole coursework to see what is the good criteria if you want to approximate. Okay, a normal approximation. So this is what you learn, right? A normal approximation is a good approximation to binomial under the condition. Okay, P is close to 0.5 and the number of trials is hey. Someone forget to let me mute you. Someone forgot to mute. Okay, it's okay. Never mind. Okay, let's continue. Okay, so I think this is not the first time and might be not the last time. Okay, so you just make sure that your hand don't touch your microphone. Okay, accidentally. Okay, so where did I stop? Okay, just now I said about condition. So if you see here, the condition, you say P close to 0.5 and the number of N is large, correct? So it's okay, never mind. Okay, it's okay. It's okay. Okay, so if you see here, the condition here is not the same condition as you do in your exam, because that one is the standard one that you say NP greater equal than 5 and NQ greater equal than 5. Yes, that one is good, but if you are in exam, because everybody will do the same thing, okay? But in general, we want to discuss what are the effects when we increase N or increase P or decrease the N or decrease the P. So what would the value affect your approximation? Okay, so when the number of size increases, the number of trial increases, you want to see your approximation is better or is worse. So that is the thing you need to identify later. Okay, but this is for the binomial. He already give the introduction. Okay, so let's look at task 1 for binomial. Okay, for binomial is the actual one. So this one, keep in mind that binomial is the actual one and we use Poisson to approximate it. Okay, to approximate it. Okay. If I put an I should binomial to Poisson, correct? Binomial become Poisson, okay? Means we use Poisson to approximate binomial, okay? Like that, okay? Now, look at the part A. So we need to compare what we need to compare. We need to compare their PDF, okay? We need to compare the probabilities, or Px equal to 0. We want to see how much is the difference. Px equal to 1, how much is the difference, and so on, okay? So for all the possible combinations of n and p, where n is, you can take two values, 10 and 20, you want to see the difference. And p equal to 0.3 and 0.6, you want to see the difference also, okay? Tabulate all the probabilities, all, okay? All probabilities means, for example, if your number of trial is 10, then you want to have 0, x equal 0, x equal 1, equal 2, blah, 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 sampai 10, x equal 10, okay? You need to have all the probabilities. Using both, okay? Using both using the binomial distribution and the Poisson approximation. So you see, okay? They already stated it very clear. Poisson approximation to the binomial distribution, okay? Now, they already tell you, you only need to show the calculation clearly for n equal to 10 and p equal to 0.3. For the rest of it, you may use a calculator or Excel, okay? So we will do that for the first part, but I'm not going to do all, of course. There are 10 values or 11 values. I'm just going to show the first few. We'll write for the rest of them, okay? And illustrate graphically. So this one, graphically, you need to, of course, you can use Excel to draw, okay? But this one, maybe you can show one time using your own drawing. You use your own graph paper and draw it for one time, for the first time. Then for the rest of them, you can use a calculator or Excel, okay? And then part C, we would see that actually, I will only do that all in the Excel, but if you want to do, for example, the first one, n equal to 10, p equal to 0.3, by hand to draw the graph, is up to you, okay? Because I don't want to affect too much of your own work. I will just guiding you the things that you might don't know, okay? Okay, so let's so if you want to do in your paper, right? So you need to have all the probabilities to compare, correct? Okay. So first of all, you would say this is the px equal to x. Okay. You usually you do a row, correct? You do a row. But this time around, because there are so many values, so we try to do a column. Okay, column is easier. So here, first you put the value of x. The second one will be your calculation of the value. You just make the table as big as possible. I just show you what you need to do here. Okay. So it means that, but make sure that you tell clearly there are two ways to calculate, correct? So you state for the first one, you use binomial distribution. Maybe you better tell because you want to tell better, right? The things, what are your x? So you better tell your x is a random variable binomial with n equal to 10, p equal to 0.3. So this is the parameters value. Okay. Okay, next. So what are the formula here? Formula here, okay. You can write out the general formula. So which means you already know your 10. So 10cx. You don't know what's the x. So here. And then the winning probability 0.3 to the power of x. Your q 1 minus 0.3, which is 0.7, to the power of 10 minus x. Okay, something like this. If you like, you can put a bracket. Okay, so this is what you need to put. And how many values you need to prepare? You need to prepare 10 values, correct? Sorry, I mean 11 value, including the 0. So you start from 0. Okay. Okay, binomial, your n is 10, number of trial is 10. So maximum, you can get 10. Okay, maximum, you can get x equal to 10. So you do from 0, 1, 2. I am just going to show you the first 3 and maybe the last one. The rest of it you do on your own. Okay, because you know how to do it. Okay. So you just substitute the formula, okay? But show clearly the calculation, right? So you better put 10C0, 0.3C0, 0.10 to the power of 10, okay, because 10 minus 0 is 10. Okay, so this is the value. Okay, so you can get the value easily from your calculator, as you remember, right? Okay, from the calculator, of course lah. Okay, this one is just what we learn in the class. But today, the things is you will learn the more efficient way using Excel. So, never mind as a revision. Okay, so we can get all the values here. Right, remember? So we go to sorry, the wrong model. Okay. Okay. So you go to menu 7. This one is binomial PD. So you press 4 and you press list. There are so many values you need to have. Okay. So you want to have all the value from 0 to 11, 0 to 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Of course, you press equal, okay? So after you press all the numbers here, and you press equal one more time, so you need to key in your parameter. In this case, your n is 10, your p is 0.3. So you would have all the values here. Just copy the value there, okay? 0.00, 0.0282. I'm not sure how many you want to give. Maybe you can give 5 dp, okay? But I'm sure enough the down value all are very small, correct? So maybe you can just put like the standard, like the what do we call that? The standard form, a scientific form. Okay, you can put like that times 10 to the power of how much, because there's too small. Okay, so you put the significant figure instead. Maybe you can put 4 significant figure for all the values. Okay, so that should be fine. So I just take a screenshot. 0.028. 2825 lah, okay? 2825. Some sound there. 0.02825. Okay, 0.02825, this one. And the second one, then you check by yourself what are they. So you just show all the calculation. Okay. Just change it to be 1, 0.3 to the power of 1, 0.7 to the power of 9, okay, and so on. Okay, this one I believe you have not a big issue here. So you just show all the calculation here, okay? Complete that in your table. Okay, the thing is, you are not familiar with this one, the next one. How to use, what do we mean by using a Poisson to calculate it? Okay, so What are the relationship between the Poisson and the binomial? What can we say about that? If you want to say that they are the same, of course, we are not saying the probabilities are all the same, but we say something they have in the common. What are they? What are the things that we can say they have in common? Okay. Binomial have NP, right? Poisson have only one parameter, which is lambda, to be determined. At the same time, you know, a Poisson distribution, the lambda is actually the mean, right, of the distribution. So you want to know the mean. If you want to use this, the old binomial, so can you find the mean from the binomial so that you can say, okay, so I know how I have an approximated mean to be used. Okay, so what is the mean of this binomial distribution? So here we write Poisson approximation to the binomial distribution. You can complete the sentence. Okay, to the you can complete to the binomial distribution, but for simple, I just say Poisson approximation. Okay. Okay, so here is the question mark. We're not sure what are the numbers. Okay, so the things that you know actually is the mean. You need to calculate the mean from the binomial distribution, correct? Okay, so I just do it here. Okay, so from this binomial, the mean is actually equal to a mean, or EX is NP, right? For binomial, correct? So we know it's NP. So it's 10 multiplied 0.3, and you get 3. Which means if you want to say a Poisson can be approximate, okay, so you would say the lambda is equal to 3 because of the mean, okay? Because we all know lambda is the mean. At the same time, it is also the variance of a Poisson distribution, okay? So this is what we can say. This is what we need to do before we use an approximation, okay? And after that, you know how to calculate the probability, right? So just to give you the formula. So you have the formula for Poisson, E negative lambda, which is 3, lambda to multiply by lambda to the power of x over x factorial. Okay. So show the first few calculation, which is when x equal to 0. So you just do this one. When x equal to 0, you have 3 power 0 over 0 factorial. So what are the number here? And what are the number here? Okay, equal to how much? Okay, and until your last, until 11, okay, until 11. Okay, so of course, the calculation you show by yourself, I'm just going to give you, attach you the answer here, and you use a calculator, okay? So one more time, we press menu 7. So now we want Poisson PD, we go down and then press 2, list all the values from 0 to 10, correct? You can check that. And then press equal. So your Poisson, your lambda is equal to 3. Okay? You can follow, huh? Then you check all the values. Okay, of course you can take 3 or 4 significant figure. Okay? Okay, so maybe 0.04979. 4979 lah. So 4979. Okay, so you see the final value also very small. Okay, 0.04979. Okay, and all that you complete. Okay, just attach this one. So this is the part A, correct? Part A, show the calculation clearly for n equal to 10, p equal to 0.3. Okay, now when we want to do more and more, okay, for the graphically, yes. Wait, can you write e power -3? What do you mean? You mean the answer here? You write in terms of e power -3, this one? Okay. Just try to give values because this is statistic. In statistic, normally with the number we can see clearly. Okay. If it is in calculus M2, then you leave your answer like this, no problem. Okay, but statistic, we want to compare all the values here. So you better give the decimal number, decimal form. Okay. Then because later you want to compare the value, correct? If you put in e-3, it's difficult to compare with this one, right? Okay, now you see something, just now we say this is the approximation to this. So meaning that after I get all the values, I need this value to very close to this one. But for now, maybe it's difficult for you to see that are very close. Let's give two more value. I lost my data already. I use my own calculator faster, okay? Wait, Okay, let's give the first three values, okay? Let's give the first three value. Okay, this one is 0.12106. 10 C2 0.3 power 2 0.7 power 8 0.23347. Okay, so this one more. 2 factorial. Okay, so I'm going to give 7 Poisson lambda 3. Okay, so the values are, this one is 0.14936. Okay, anyway, I'm just going to give the first 5 decimal places for the first few values. If you're trying to make a simple comparison, do you think the value are close? Yes, a bit close, correct. The difference is maybe 0.01 or 0.02. Quite small, but not very close. As you will see later, we will have a more perfect one. So this is just a very simple approximation. Okay, they are close, but not very close. Okay, this is what you mean by show the calculation. Okay, so we have done for the part A, right? Okay, for illustrate the graphically, maybe you need a tool here. So starting here, you all have the paper already, correct? Yeah, okay, take a screenshot or you all have your own paper, refer to it. Okay, I won't go back to this. I just read only later, okay? Because I want to show the screen of my laptop now. Okay. So let's go for Excel. Okay, all can see. Okay, this is a standard Excel. Okay. I need to open your chat. Wait, let me put here. Okay, now, so what do we do here? Okay, we will do that. You will check for your instruction. You need to do a graph. Okay, never mind. We do that later. And you look at the part C together. Calculate the mean of the absolute difference between the probability of two distribution, which means you want to get the difference. As I said just now, you want to compare the two values. Okay, for each of the row. Okay, you compare the values. That's why I make a column. Okay, tabulate the value and comment of the closeness, okay, closeness of the probability obtained. Okay, and because you need to do for all, correct? You need to do for all the possible combination of NP. how many possible combination you need to do. Just now you only do n equal to 10, p equal to 0.3. You need to have n equal to 10, p equal to 0.6. Another case. And when n equal to 20, p equal to 0.3, and n equal to 20, p equal to 0.6. So here you have 4 cases at least you need to do for part A to C lah. Because you see, they want you to repeat the step. Repeat the step, okay, ABC. So for each of the case you need to do the graph, you need to calculate the things. So of course, if you do manually, okay, you can do it few days, okay? Okay, so we use Excel. Okay, now what do you do first is, okay, first you say what is your, of course you say, you do each of the case separate by different sheets, okay? So you have sheets 1, then you press this down button, okay, add a new sheet, then this is a new case, okay? Because you do all the things in one sheets, okay? Okay, so for this one, you can say what is your, you state what is your values of n and p that, okay? So binomial, for binomial, you have, what are the parameters you have, okay? So this is the distribution. Distribution. So, and then this is a parameter. Okay, and the value of the parameter. Okay, so for binomial, you have 2 parameters. I merge it. So you need to have your n and p. And for the Poisson approximation, okay, like this, okay? You only have one, right? Which is lambda. Lambda, or you can know it as your mean, okay? Lambda or your mean. Excel cannot, Excel is not, you cannot type the symbol here, okay? So I just use the name, okay? Lambda, LAMBDA somehow, okay? So now, all the values of the NP and the lambda that we just discussed just now, you tabulate here, which is n equal to 10. P equal to 0.3. This one is equal to 3. Okay? So state clearly what you are doing, okay? Don't straight away start from just giving all the probabilities. We won't know what you are doing. You must have your title, okay? Or you must have the you do anything, you must have your title correct, or the tell the people what you are doing. Okay. So as we say, we are going to do the first column, sorry, you are going to put your small x. Okay. Your small x is going to run from 0. Okay, let's double check all the things with our Excel calculator. Okay. So that will be very fast. Okay, first you must have your x, and then second, you must have your px equal to small x. Okay. Yeah. If you don't know how to type anything, just let me know. Okay. Okay, why I put 2 px equal to x? Because 1 is for the binomial, the original binomial. So you can say this is a binomial distribution. Okay. Okay, cannot see, just, or you can make 2 row. Comment. I don't know, shift enter or what, somewhat. Okay, you make. Okay. But I can let the table of the binomial can make bigger. How let the table of binomial become bigger? You mean merge, is it? Okay, you have a problem with the merge, is it? Okay, you drag the two things. Okay, you search something here, which is called a merge and center. You press it for the binomial just now, right? Okay, I redo again. This one is without, correct? You have something like this, right? So you just drag, press, merge and center. Okay? Can I no problem, huh? Anything you can ask me, okay? Okay, so for binomial distribution, okay, because I want to show the formula if possible, okay? Just want to type the formula so that everybody understand what we are doing. Just want to let it go down. Okay. How can I do that? Shift enter. Okay. Anyway, you use your shift enter, okay? Because mine is option enter, option written somehow. Okay. You can do that, or you just make a longer row, but it's not nice. So you just do like this, make it go down. Okay, for binomial distribution, I just try to write a simple things like how is the formula going to look like. Okay, so the formula is you have okay NCR that NCX, okay that something. Okay, before that I would show you the first calculation, then only I put something over here. Okay, then you know what does it mean. Okay, now for the next row, this one is next column, Poisson approximation. If you want to be more specific, Poisson approximation to the binomial distribution, whatever. Okay. Okay. Somehow. Okay. All right. So next, you need to put all your 0, 1, 2, and so on, right? But no need to do that for type one by one. Okay, you have a shortcut. After you type 0 and 1, Excel understand you want to say 0, 1, 2, 3, and so on. So you just press your 0 and drag to 1. Okay. And then move your arrow to the right bottom corner of this 2 cell. And then press and drag up. During the time you drag, you would see the number. For example, here now is 7. So it means it would do me for 0, 1 until 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7. But I want more. I want how many? I want 10. So you just do until 10. Okay. This is the value of X. Huh? Okay, so I believe that you all maybe know this one. If you see just now, actually I did something wrong in the writing there. I actually put the X until 11, but actually just stop until 10. You all just make your changes there. Okay, I'm not going to show you back. Okay, just now I accidentally do 11. Okay, in the writing there, but just stop until 10. Okay. Okay, so now you want to get all the values, right? Okay, now here, how to do it? Okay, of course, you don't calculate on your own and then put the number into Excel. Nobody will do that. You will let Excel calculate for you. All right. So here you have 2 ways to do this. You have 2 ways to do this. You can choose either one, but I will teach both to you. Okay. Number 1 is we use the calculation, the normal calculation that we have. So you understand the formula. So you will press the formula one by one, all the things. But let me show you that something that in Excel, you need to know the function. Okay. I'm not sure whether you know about Excel function, but let me show you for example, the first one, how to calculate. We have 10C0, 0.3 to the power of 0, 0.7 to the power of 10, correct? So how would you type that in your function here? Okay, first, if you want to calculate value, you must press equal. If you don't press equal, it won't show you anything. Okay, I give you an example. Let's say you want to calculate what is 2 plus 3. So if you type 2 plus 3, and press enter, it would just show you 2 plus 3. They didn't calculate for you. Just display the 2 plus 3. If you want to calculate 2 plus 3, so you go to the edit bar here, you see the fx here, the function. Okay, go wait before you even start the row, press equal. So if you have the equal, then you press one more time enter, then you will get the value they calculate. And if you go back to this cell, display is showing here. This one is the calculated answer, and during the formula bar, you see here, the formula bar, it will still show you the 2 plus 3, the thing that you enter, the input, and this is the output. Okay, so this is the Excel basic. Okay, so later we will all use that. So we would now type the function or the formulas here in the formula bar, and the output will give us a value. Okay, so before anything you start, press equal. Okay, you want to calculate something. Okay, first thing is 10C0. You don't press 10C0 like this. They will not calculate anything for you. Excel, that has a specific form. Okay, for this C, choose or the combination. Okay, combination. The function name is called combine. C-O-M. You can type. Okay, you see, when you type, they will show you something here. What does it mean? You have Excel got so many functions. Okay, so different function will calculate the different thing for you lah. So now what you want is actually combination C that do the same work as your calculator did, but you don't type exactly the same thing in your casual calculator, right? So the name of this function is called combine, C-O-M-B-I-N, or if you see that, you can just press it. Okay, C-O-M-B-I-N. After that, if you type C-O-M-B-I-N, okay, upper lowercase doesn't matter, I think. Okay, and then you must put an open bracket before you key in your input. Put open bracket, then here is the time you need to put the values. And you see here, that would show you, I think that would show you regardless of your version. Okay, the first thing you need to press is the number, and the second one is the number chosen. Means this is your N, this is your R. Number chosen is your R, NCR, correct? So the first thing you put is your N. Okay, okay, N is 10, but you don't type 10 like this. You want to do also can, but I would prefer doing this, which is just now you already type your value of N is equal to 10 already, correct? So I'm just going to move your arrow to the 10 and click the 10 here. Okay, so it would show you what in the formula bar here. If you see, they show you the place where this 10 is at. This 10 is at the position C column, row 2. So that's why it is C2. Depends on your own thing. Like if you put different format, like how I did, then you will have a different position. But the position is this one, the number 10. Okay? Okay. You see what we get, huh? And then you press comma. You press comma, then you need to type your second thing, which is the number you choose. Now I would type 0. I will press the 0 that beside me. Okay? It means 10C0. 10C0 is what? 10C0 is 1, correct? Okay, now don't forget to close your bracket. Okay, if I just want to stop here and I press enter, you will see the number 1. Means they already calculate for you what is 10C1. Okay? So the logic works like this. All right? But we haven't finished yet. So we continue, go to the formula bar here to edit. Okay, we need to multiply by 0.3 power 0. We all know that that is equal to 1. But never mind. I want to show like a mechanic. So later it's easier for us to do for the rest of the number. Okay, so you must do this, which is multiply symbol in your laptop, in Excel function, is the asterisk symbol, the star. Okay, as I'm going to show you here, this one, asterisk symbol. Okay, for those of you who don't know where is it, you press Shift 8. Shift 8. You will see the asterisk symbol, correct? I believe that all your laptop is the same. Who cannot get? Just give me a reaction if you're okay with this, huh? Okay. Okay, can. Okay. Okay, next. Okay, asterisk mean multiply lah. Multiply by 0.3 to the power of, okay, to the power of is this one, okay? The upper arrow like that. That one is shift 6, okay, in your laptop, okay? To the power of 0. For now, you press 0, but you don't. Okay, actually, sorry. Just now the 0.3, I also want to refer to the numbers here, as you will see why it will be better later. Okay, I just go back. Okay, I use your mouse to click the formula bar there. Okay, I don't want to use 0.3. I want to use this value, even though they are the same number. Okay, so C3, this one, to the power of 0. 0, again, I'm going to click this one. Okay, the X here. Okay, if you think this one is too messy, sometimes I will do a manual open bracket and close bracket here in order for you to understand that, oh, this is the first thing, 10C0, and then multiply by, this one is 10 power 0. Sorry, 0.3 power 0. Okay. Okay. So the next one is Q power 10. Okay. But what you are going to do here also similar. You need to base on all these values. Okay. So I would say multiply by, open the bracket. Now, the value of Q is 1 minus P, correct? 1 minus P, huh? Okay. So what I would do is I press 1 minus and then I click the P. And then I close the bracket first, because that is the value of Q. And to the power of 10, correct? Okay, so now think in your mind, what is 10? 10 is actually, if referring to our formula, is actually 10 minus 0. Okay, that will be better. So here, I open the bracket now for 10 minus the 0. So again, I'm going to click my n minus x. Okay, so this is the power. So if you want to, actually from here, you can already get the answer, but if you want to be more nicely, then you can put an open and a close bracket here, which means this is your Q to the power of what is this called? N minus x. Okay. All right. Can you follow here? So far so good. If you press OK, then you would get the value. Check that is exactly the same as what you get just now in your writing. Okay. So just now you round off, but Excel, one thing is good that can go for many values. So even this 125 is not the end in the Excel, inside the Excel. They just display this number, but actually what the proper value they store, they got much more decimal places here. Okay. Okay. So now, I just want to retype it. If you can't follow, I just type the things that you need to do, which is the first thing is combine. I just write it out. Okay, combine means C, NCX. Okay, so I just put N comma X, means that you what the things you need to put, but you click the number here N. Okay, and then CX. Okay, multiply by, in the bracket, Q power X, and then multiply by, sorry, just now is P power X, now is Q power N minus X, which is, but if I don't want to write the Q, then I write 1 minus P to the power of N minus X. Close bracket, close bracket. If this one is too messy, put some more space so that you can see it clearly, the formula here. Somehow, I don't know why, here I cannot. Here we'll have a, I'm not sure why lah. Okay, okay. All right, can you see here? So which means this one is the things that you actually put here, but just now I put all the value, but here I show you the formula actually. Okay. All right, so far so good. Now we want to duplicate. We want to copy and paste the formula so that we won't type at again. Okay, but now you have a problem. If you straight away from this cell, you drag it, then you would see a problem. Why sometimes got the number and sometimes got the value. So you're not sure, if you're not sure what's the problem, then you go to the number here part, and if click on the formula bar now, you would see a problem. Okay, the X already go down, no problem. But actually, during all the process, my value of M and N is actually fixed. So if you just drag it down, they would think like, oh, all the values are going down, including the value of N and P. Whereas they go down, they have no values here. So you want to fix that. You want to fix the value of N and P throughout the whole process. So what do you do here is, okay, go back to the formula just now. Click on the formula bar. We will do something here, which is the value of N and P. So just now we use C2, correct? So according to mine one is C2 lah. So you go to your value where you put your 10 here. Okay. So if you want to fix the position, okay, throughout the repeated process, then what you need to do is you put a shift number 4, a dollar sign here. Put a dollar in front of the C and also put a dollar in front of the 2 so that you can fix this cell during the process. Okay. What else you fix? So all the things that you fix, then you just put this one. Okay. So it means that the purple color also the same, right? The C3 will also need to fix it. So you put one more time, is shift 4, shift 4. Shift 4, you have a dollar here. Okay, next. Okay, again, you have a C3, so dollar. Okay, one last time, you have M minus X. Again, the N is also, you need to put dollar. So during the first formula, actually, the 4 cells, I need to add the dollar sign. And one more time, if I press equal, of course, the value is not going to change. But when I drag it, it will be nicely done. It will give me all the values I need. Okay, because why? Because if you go to the second cell and if you look at the formula bar here, now all the blue color and the purple color, which is my N and P, is not changing. Okay, this is what we call somehow absolute position, I think so. Okay, means that you didn't move it, you fix the number, but you move the value of X. Okay, but you see all the red color number, all the X is going down as you go down, right? As you go down. So that's why the value is different. Okay, if you look at the first 3 value, or if you check all the values here, it's exactly the same as what you did in your paper, correct? You check the first 3 number, you know lah, right? 0.028247. Okay, this one 12106 just now was the same, and 23347. Okay, exactly the same. Any questions so far? Okay, no, okay, now we go for Poisson approximation. Okay, Poisson approximation. So if we use the same method, which means we want to calculate exactly like how we do this one, the formula here. Okay, so now I'm just going to show you how to type. Okay, I will go for the formula bar first. I will type it for you. So later on, you can press. First, exponent e to the power of negative lambda, correct? So I'm just going to put here, okay, e power, if you put the number e, the Excel won't have this value. Okay, Excel don't have this value. Okay, so they only have this value if you press exp only. Okay, wait. I'm going to show you what does it mean. If you want to get the specific number E only 2.7 something, then what you do in Excel is you press equal, you press exp, means an exponential function. And if you press open bracket, you press 1. That's going to give you the value of E. What does it mean by 1? It means E power 1. Exponent to the 1. E power 1. That's why you have this. If you press E power 2, it's going to be, I think, 9 something. Or I mean 7 something, is it? 7 something. This one, E squared. Okay? exp2 means E squared. Okay? The values here. So now, if you want to have E to the power of negative lambda, so later you just need to type exp in the bracket. In the bracket, you want to put negative lambda. Am I right? Because E to the power of negative lambda, so inside the exp, you put negative lambda, right? Negative lambda. I just write like this because this one just for showing you only. This is not any formula. This is not the calculation in Excel. This one is just to show the people to understand. Okay. exp negative lambda, later I need to multiply by lambda to the power x. Okay, lambda to the power of x. So I press open close bracket. Lambda to the power of x. Is it okay? Here, you just look at here. And then divide by, okay, another thing, divide by, you don't have any division symbol in your keyboard, right? So the division is the slash. Slash, not not the backslash, it's different. This one is a normal slash, okay? It's shift question mark. Shift question mark, sorry. If you press the shift, you will get the question mark. If you don't press the shift, then you will get this one. You will get the slash. Okay. Means the division symbol. The division operation is here. Divide by x factorial. Okay. So factorial is another function in Excel is FACT. I think so. Factorial. So inside the factorial, you just put your x here. Okay. Rearrange it. Make it nicer. Okay, so this is what you're going to have. Later, you see what we type, is it the same? Okay, let's do for the first row, then you will understand what does it mean. Okay, so now I'm going to do equal. First thing is exponent e to the power of -3, correct? So exp to the power of negative lambda. My lambda is 3. So I'm going to click my 3 here. Okay, you press the close bracket, but then remember, later you want to copy paste, right? But you want to make sure also your lambda is a fixed value. So what do you do here is you go to your C4 here, you put the dollar sign also, put a dollar symbol, because you want to make it as a fixed number, right? Okay, next, you need to multiply by lambda to the power of x. You see here lambda power x, okay? So meaning that once again, open bracket, lambda value, this one, okay? Of course, you can put the dollar sign here if you want. Sorry. Okay, you don't move the one, if you use your keyboard, okay? You better use a mouse to click here, okay? Click and put the add the dollar sign on your own, okay? To the power of x, once again, shift 6 to the power of x, so you click this 0. This 0, no need to put the dollar sign because the 0 is going to change. Your value of x is going to change, correct? Okay, and then close bracket, and then divided by, so you press this slash, divided by x factorial. So FACT, you can see here, FACT. Click, okay, actually FACT lah, okay, means a factorial function. So inside here, you just need to put your number 0 and then close bracket. All right, can follow? So the lambda, you need to put the dollar, X, no need to put the dollar symbol. And once again, equal, then you would get the value, correct? 0.04979, 49787, okay? Yeah. All right. So later you would drag for all the values here, then you would get the same thing, lah, right? And double check the first three value. If it is correct, then the rest of it will be correct. Okay? So far, so good. Okay, good. Can. All right, this is the first version, as I said just now, right? This is the first version, as I said just now. Okay, the first version means that I say you can copy this one, right? Copy and paste. Okay. Okay, now I'm going to show you a second way to get the exactly same thing without using all this. All right. Okay, you can choose either one. If you're okay with this, then go ahead. Now, copy, I'm going to go to my Sheets tool and I paste everything here. Okay, paste everything here. Except for the values here, the calculation is going to be different. Okay, and give it a new highlight color. This one. Okay. Sorry, my eye cannot. Okay, later only I put. Okay, let's put no fill first. Okay, now the formula here is a little bit different. It's not a little bit, it's very much different. Okay, I'm going to retype it. So here, what I'm going to introduce you is Excel actually have a function to calculate the binomial distribution probability automatically. You just need to tell what is the value of NPX only. That will calculate for you. Okay, it's just like how you enter in your calculator, you tell them what is the value of N, P, and what you need to calculate for the X value. These three things enough, then they will show you the values. Okay, you no need to do all the factorial, all the power things, no need. Okay, so what are they? Okay, the function name is called, let me show you here first, okay? I just type it out. Okay, binom, binom, stop there, and full stop, dist. Okay. I think I'm just going to show you here. Okay, I think this one is easier that everyone of you can follow. Okay. The first number, right? Okay. So you press equal. binom, right? You can check here. Binom.dist distribution, binomial distribution. You want this? I click this one. I think every one of you will have this function. Am I right? Because different version will have different function, but this one is a very old function already. So I'm sure that 10 years ago should have this already. If some of your Excel will have this one, binomdist without the dot, but actually they did exactly the same job. Just that some of the version, I think, don't have this one. This is the new function, I think. Okay, so I'm sure that every one of you will have this one, the .dist. Is it? Other. Okay. So you can see these three things. What they want you to put. Okay, actually it's four things. I will explain to you what does it mean by cumulative. Okay. First is the number of your, what they put, number S, okay? Number of your success, okay? Number of your success, you see? Number S means the number of success, means your X, okay? So for this one, press your 0 here, okay? Your 0. Okay, this one later will go down, so you no need to put the dollar symbol. Okay, next, put a comma. And the next thing is the trial, number of trial, which is your value of N. So this one, click the 10, but you need to fix this value throughout the process. So you add a $sign in front of it. Okay, $C, $2. Okay, put comma. Next is the probability of success, S, success, okay, which is 0.3, your P, all right? So this one also need to fix. So you go to put a $sign. Okay. Last, if you press comma, they would tell you, okay, what does this one mean? Actually, binomial function, there are two binomial function. One is CDF, one is PDF. Which one you want to give? Now here I want to give the PDF, right? I want the probability distribution function, or PMF, as I tell you last time, the proper name of it is probability mass function. So we want this one. Okay, if you have this option, then you just click the false. Okay, if you don't have, you can type also. You can type. If you have, you just click the false, then you will have this one. If you don't have, just type FALSE, and then close the bracket. All right, and then press enter. Then you would have this also. If you go here, you can check this. The formula is very much different from this one, right? Which one do you think is easier? I think this one is easier, right? Correct. Okay. Now, if you do for the rest, you can check the value with this one. Are they the same? Yeah, exactly the same, right? Exactly the same. Okay. So I'm just going to make one more time revision. So you press binom.dist and open bracket. The first thing you put is actually your x. The second thing you put is your n. Third thing is your p. The last one, you just put false. Close bracket. Okay. So inside the formula, you do this thing. All right. Okay. Now for Poisson, we would also have the same thing, similar thing, which is POI. Sorry, I forgot the name already. Just let me check that. Okay. POISSON.dist. So you type the full name Poisson and then .dist distribution. Okay. So here also have the same thing. Okay, let's just do this one first. Poisson dot distribution, open bracket. Only three input you need to have. Number one is your x, which is your 0 lah, okay, which is your x, okay. And this one you need to go down, so okay, and you press it, comma. The next thing is the mean. Mean is the same as your lambda, right? That's why actually I put a mean here. Means that you clicking your lambda. Okay. Make sure that your lambda doesn't change. So in the formula bar, put $. Okay. Last, here also press false because I want the PDF also. And close bracket, equal, you would get the number here. And drag that. For all this, you will have the same number like just now. You can compare. Exactly the same. Okay, exactly the same. All right, just going to write out the revision here. You can refer DIST. First thing you put is your x. Second thing you put is the mean. I just put lambda. Okay. The third thing is just put false. Close bracket. Okay. This one. All right. So far so good. So here I provide you two ways to do for the rest of it. You can choose either one if you show both. Okay. Who cares? The teachers care only. Okay. So but throughout all this one, I think I would prefer using this because this is something new for you, right? So typing this one is difficult in here, but you know the formula, right, already, correct? You're going to face it for the rest of your SEM 3. So now let's do some new thing, which is we get used to it with the function here, okay? Excel provide a fantastic function, so we can just find it. Okay. All right. So no problem for this one. Everyone okay? Can follow, Okay. Now, next. Okay, good. Okay. Next thing is okay. I just use the second one. All right, because it's the same thing, but you just choose either one. Okay, I'm just going to use the second one. Okay, then continue to do the next part. What do we want? Okay, the next part is can I finish all that for all the 4 cases first? Then only I do the graph. So I do part A 4 together and then part B all 4 together. That one is easier, okay? Because I'm explaining a concept by concept. Okay. One thing you can do better is you can label the name of your sheets. This one is when n equal to 10 and when p equal to 0.3. You can write this one here. Okay. Wait. P equal to small n. Just okay. So you know which one you are doing. Okay, so let's do a new one, which is let's go for n equal to 10, but when p equal to 0.6. Okay, so open a new sheet, but no need to do again the same thing. You just click here and press Command C, copy. Okay, and go to the new sheet, press exactly same the left top corner here and press Command V. Copy paste shortcut, you know, right? Then you can have the exactly same thing, right? Correct. Okay, now in this one, you can label first. You want to do n equal to 10, comma p equal to 0.6. Okay. So now you just going to you change this value to become 0.6, and you guess what happened. If you guess that only the things happen here, okay, and happen to this one only, then you are wrong. If you press yes, then all the values here are changing, right? All the value here for the binomial distribution are actually changing. Okay. Why this one haven't changed here? Because my lambda is still equal to 3. Okay, so now one thing you can do for the lambda is instead of typing 3 or typing if you calculate is equal to 6, correct? Because 10 multiplied by 0.6 is equal to 6. But what you do is it's easier. You just type equal. You say you want to use these two multiply together. Okay, so it's 10 multiply 0.6 and press equal. Then this one is equal to 6 already. Then you see one thing at Excel is really excellent is you no need to do it again. When by the time you change your parameter here, all the values are actually changing also. You see, all the value changed already, right? You compare this one, compare this one, all the values already changed. Correct. See, the first one is already different. Okay, first one is already different. Okay. All right, so meaning that this one 3 actually just now you can do equal to 10 multiply 0.3 lah. Okay, even though it's the same thing. But we make a good habit, which is in the Excel, try to when you type anything, try to base on the previous thing. Then when you change one thing, everything is going to change together. So no need to do it again. Okay, so you see you see why just now I say all these things you have to base on the previous thing. This is the reason. Okay, this is the reason why. Okay, so far so good. Just change these two value and you will see all the changes here. You get it? Okay, I don't want to use the yellow color first. This one is okay. Okay, this one looks better. Okay, so now, okay, so we're already done for this one, right? We're already done for n equal to 10 and equal to 0.6. You see, all the things we need to do is just change the value here only. Actually, you just change the p, then the lambda supposedly automatically change by itself. Okay, now Number 3, we want n equal to 20 and p equal to 0.3 first, okay? You guess what you can what you can have. If you think that only changing the value, that is okay. I tell you first. Okay, now if you copy paste, right? You do the same thing lah, like just now. Okay, copy paste, okay. And then you say, okay, let's change. You see, I go to this one change because this is p equal to 0.3, so no need to change the p lah. I just change the n. From the n equal to 10, I change to n equal to 20. And you see, when I change this one to 20, my lambda will change together, become 6 also. Now this is 6, but it is because the n 20 multiplied by 0.3, and you get 6 here. Okay. Understand instruction here? Okay, never mind. I think it should be fine. Never mind. Let's finish first. Okay, now here is there's a problem. This one again. Okay, actually there's a problem here. Now, what do you need to have an extra thing? If you think that is just the n, of course it's not. What extra thing? Now n is equal to 20. What do you expect here? Do you think it is just up to 10 and to stop? So what do you need to have? You need to have more values, right? Until 20. So 20. Okay. Now one thing you can do is, yeah, look properly, yeah. Okay, I just do only. Okay, click this one, drag to here. Okay, and from the right bottom corner, drag down, which means you do the same job for both sides together. First, you add the values of x first. You cannot do 3 things together, but you must add the x first because these all values depends on the x. So you must do the x first, then only you can do this one. Okay. Okay. Can get all the values, Okay. One thing you can check, which is now from the theory of probability, random variable, if you plus this all number, what should you expect? What do you think is the number when you plus all the number here? What do you think it should equal to? It should equal to what? The summation of px equal to x is equal to what? The one that you do. Yes, equal to 1, right? The condition for a probability, condition for a discrete random variable, okay, as well as for the continuous, but continuous is an integration. This one is a summation, right? So here you can apply this one. You want to double check, is it all the calculation correct? Okay, so what you can do is you plus this all value, see is it equal to 1, that is a double checking for all the value, okay? So what do you do here is, of course, you're not plussing one by one. You just do a quick check. You press equal to the sum, SUM. Means you plus all the values and open the bracket. You see here type number 1, comma, number 2. Of course, you don't do that. You use your mouse to click from here, drag to here. Means you are plussing all the numbers from here to here. Close bracket, equal. Is it equal to 1? Yes, equal to 1. Same for this one. Okay, let's do sum. Now I'm go back to the 10 and 0.3 already. Just go back to the first one. That is also, that is not equal to 1. Why? Can you explain to me why is it not equal to 1? Because why? You see, okay, binomial, all the values from 0 to 10, you get add up to 1. but not for the Poisson. Poisson, if you add this one, you add from 0 to 10, it only gets 0.99970, not until 1. Why is it so? You can give yourself a 1 minute to think about this. Okay. Okay, for those of you who watch the recording, you all think on your own first. Yes, okay. So okay, some of your answer here is very well. Yes, approximate only, correct. It is just an approximate only. It can be close to binomial, but not exactly same, right? So it would not be perfect one. Because as you know, Poisson have many, many values more, right? You don't stop at any point. As what I say, I normally say it's at no limit, no maximum. Okay, so you can, for Poisson, you can go up to 11, 12. That one will still have value, even though it is very small, right? If you plus all that, baru equal to 1. You plus so on, many, many numbers. But now we don't do that because we say it is an approximation to binomial. We want to check is it true or not. So we only do up to 10. So what we see here is the number is the summation is not equal to 1 exactly, but that is fine because it is just an approximation, right? It's just an approximation. Okay, so you can do the same for all the rest of this also. What happened? Okay, so here you have the same problem here. This one is even worse. You see, this one is close to 1, but the case where n equal to 10, p equal to 0.6, you see, 0.95, which is not that close to 1 compared to this one, correct? This is something that you can, later you can say also, right? But don't worry, later we have another comparison. Okay, now this one 20, okay, you can double check it. Okay, first thing that you can guess is if you do the sum from you can drag lah, if you don't want to drag, you can type also. What I mean by type is after you press equal sum and open the bracket, right? You just use your keyboard, go up 1. Okay, go up 1, and then press shift and go up to here, and then just press return without closing any bracket. That should be fine. That will do that automatically for you. But that one is some shortcut lah. You just follow. If you cannot, just follow what I teach you just now. Okay, click open bracket, click from here to here, and then close bracket, enter. Okay, that will give you the value. Okay, so you see, now you see this one is also equal to 1. If you only do up to 10, of course you cannot get 1 also. But one thing you must make sure is because binomial is the perfect one. So if you plus all the numbers for binomial, you should get exactly 1. Okay, exactly 1. Same goes to this approximation. If you do, you can't get 1. But this is even closer, 9999998. Okay, it's a very good approximation somehow. All right. Okay, then later you will see why. Why is it so? Okay, of course, one more we need to do. So just copy paste. This is when n equal to 20, p equal to 0.6. I'm just going to copy this one. Actually, you don't need to press that one also, just paste on it, okay? Just sometimes cannot. Okay, change the 0.3 to 0.6, then you would change automatically all the values. All right. So, we have finished for part A. Okay, all the probabilities are here. Can. Okay. Now, wait. Okay. let me just continue from, okay, so now we need to do the part B, illustrate graphically the probability distribution. You want to make it a graph. What does it mean by a graph? A PMF graph, probability mass function graph, okay? So you need to have, you remember what is a probability mass function graph? Okay, last time I taught in the class that we will draw one line, put a dot, one line, put a dot, one line, put a dot, that one, okay? So now, in order to do graphically, Excel can done it very quickly for you. So what you need to do is, now this is a set of value, right? So later, what you want is actually, you want 0 to 10, all this value plot in the y-axis, right? The height of them. And the x value is 0, 1, 2, 3, up to 10. Okay? You also want these together because you want to straight away make a comparison between them. So what can you do is, you click here, you click and then press, drag for these two columns, all the values you want here. Okay, from this one, 0.028, drag to 0.0008, and now go back to 10 and 0.3 already. Okay. And you go to insert. Can you see my arrow here? Go to insert. Okay, I'm not sure whether you have this or not, recommended charts. Do you have this? If you have, if you press, do you have the recommended chart? Now you see, they already generate few of the different type of graph for you already. Okay, so that is so convenient that you just choose which one you want. Which one I want? Which one do you think can best represent our information that we want? That one that can show you the comparison between the type of them. I guess this one, column chart, right? Yes. Column chart, yes, the column lah. Okay, so the column chart is, yes, one of the best. Why I say one of the best? Because this is your own assignment. I would leave it for you to choose your own graph or design your own graph by your own. And this one I don't think is needed for me lah. You all learn in your KK, correct? I think your PA KK you all learn this also as well, right? Do you all learn this and analyze the things here? Okay. One thing that I personally think also not that okay to do is the line chart also looks okay. Hey, why disappear? Can just do two charts, okay, to compare. You can choose either one. This both I think was okay. Okay, but line chart is a little bit I don't know, because for me, my eyes, I can see the line chart. Okay, but this one also sounds good. Looks good, right? You can compare the value directly, but of course, you don't show this one to your teacher. Then they will ask you what is your title and what is the blue, what is the orange, what are they? Of course, you must tell this one, what do we call that? The legend, right? Or the market or the not here lah. You have to change it. Okay, the legend. You have to change the name of your legend. Okay. I think just do it for one time. But I think that one you can do on your own. Okay, because I think this one you should learn in your PA already. Okay. Of course, you must have your chart title. What's your chart title? You think by your own. Okay. This one is not the things I need to teach you. Okay. I leave it for you to do on your own. The changing the legend, all that. Because okay, that one is your own job lah. Okay, design your this one. Which one is the binomial? Which one is the Poisson approximation? Which one do you think? You just compare the first value, then you know, right? I think this one should be the value you see here. If you move your mouse to this column, this bar, it will show you series 1.1. The value is 0.028 something, which means the binomial one. So later you can change your series 1 to binomial. Okay. For now I cannot change the things. I somehow the vision blocked me. Okay, so this one you do on your own, okay? But make sure that you know her. You can see how to compare, right? So you can choose either one, okay? Choose either one from these two. If you think there are any other suitable chart, you can use it also, okay? Because it's just a different way to represent it, okay? But don't say you want to use what are something else. Let's take a not good example. For example, if you take this one, do you think you can compare directly? Why is this one not as good as this one? The left one is not as good as the right one because you cannot compare the value directly, right? This one you can see the height difference. You know exactly, for example, you see when x equal to 3, you know the blue color is taller than the orange color one. So you know which one is higher and you know how much is the difference. For example, when it's equal x is equal to 4, you see the difference is very much, right? Then it's another indicator. But compared to this one, you can't have a direct comparison, right? So that's why this is not a good example. But line is okay because you can see which one is higher, okay? So that's much only I want to say for the graphically things, okay? You do that the same for the rest of your, this 1, 2, 3, 4, okay? The blue color is which probability? Blue color is this one, this one. The if I think if you do like this, the first one will be your first one, this one. Or you just compare the value directly, 0.02, 0.04. The orange color is higher, right? Then you see, you click this one, or the blue color, it actually will show you the direction here, right? I'm not sure where already. Can I do this? I'm not sure. You just change the legend by your own. Format legend entry. I'm not sure. Okay, you do this by your own, okay? This is your own homework. Okay. That's much as I can help for the graph. Okay, you design on your own. Okay, I just want to have a quick review on all the graph to I think not necessary good. Okay, never mind lah. I just do one. You can see what are the rest of them. Okay, you can have a direct comparison. Okay, I just want to show another one maybe. Okay, never mind. Let's do for the same for the next one also. Okay, for n equal to 10 as well, but p equal to 0.6. We just compare the first two, see what are the difference. You make sure that you use the same chart, okay? For example, I personally prefer the line chart, so I will use the line chart. Hey, what happened? Once again. Okay. Okay. Hey, what happened here? Okay, like this. Okay, so if we compare directly, this one I just put here. Okay, if we compare directly this one and this graph, which one do you think intuitionally, which one is closer? I mean, when is which is the case that they are closer to each other? Do you think p equal to 0.3 are closer or 0.6 are closer? By seeing this only, okay? Use your eye to see. Which one is better? Which one is a better approximation? Use your intuition. This one, the gap is very big one. Am I right? The gap is very big one. This one, the gap is smaller, right? So what can you say? Okay, this one just a direct one, okay? But of course, apart from the graph, later we go to part C, we will have a different way to determine also. Okay, that one is more systematic. You have a value to tell you which one you would choose. Okay, so far so good. All the graphical part, okay. I just move it down. Just move it down because I want to do something later here. Okay, can continue to part C. So you all do all the graph, all that, okay, for the rest of the case. Okay, next. We go for part C. They say calculate the mean of the absolute difference between the probabilities of two distributions. What they want? Mean of absolute value. Okay, sorry, absolute difference. Sorry, yeah, absolute difference. Okay, apa maksud absolute difference? Means absolute means absolute value, right? Modulus. You take the positive of the difference. You want the difference in positive only, right? Or in other words, I say I want to compare these two values, right? So I need to minus them, but sometimes you will get the negative. You're not sure which one is bigger. So you just take the modulus in order to make the number positive. Okay? So it means the absolute difference. Okay, so let's plot a new column here. For this one, wait, the graph will move according to this length. Okay, never mind. Later only you change, okay? So here, you write your absolute difference between what? Between the values, okay? Between the probabilities of the two distribution. I don't know if you think this is not that nice and you shift enter. Okay. So now what do you do here is you need to minus them, but before you minus, you want to take the modulus of it. Okay. Here in your laptop, if you want to do modulus, what does it mean by modulus? For example, if you want to modulus -2, you should get +2, right? So you cannot type like this. Okay, sorry. You see what I'm doing here? If you think this is a modular sign, yes, correct, but it is not a function in Excel. Let's say you put -2 modulus, you press equal, press enter, it won't show you anything. Okay, it'll show you like this only. So what do you need to do is the function name is called ABS, absolute. Okay, absolute value means the modulus function. Okay, so for example, if you press ABS, open bracket, -2, then you would get +2. Okay, so this is the basic. So let's do it here. Now you are interested on the absolute value of the difference. What is difference? You use one minus the other one, but you don't care about which one is bigger. That should be okay because that would make it absolute value. So you press the first one minus the second one. Okay? And then close bracket, which means what you need to calculate is this number minus this number and take the modulus of this number. And you would do the same for the rest of all this, right? So you will drag from here to here. Okay, for example, you see B11 and E11, the difference of them. Okay, so you have all the values here. Okay, so far so good. Now it's an absolute difference. Okay. Now this is the sum, but you just double check, but it's actually not required here. I just delete it, okay? Because as I said just now, you just check on it. But that one is not required in this assignment. So what you need here is you need to calculate the mean of the absolute difference. Now you have many of the absolute difference. You need to get the mean value. Okay, the average. What is the average difference? The average difference. So here you say the average value or mean of absolute differences. Okay, simple. I just make it bigger. Okay. How are you seeing my screen here? Somehow the field here, can I just close it? I don't know why. Okay. Because I want to see your chat, so I will not using the right hand side anymore. Okay. The mean of the absolute difference. Okay, so you take the average. So you no need to plus and divide by the number. You have a formula for that, right? Calculate the mean of it, but it's not MEN mean, but it's average. Average function, average function. And then open the bracket, just click all this number, close bracket, and this value will be your mean of absolute difference. Let me check that. All right. So far so good. So should it be fine? I think we already complete the part C here. Tabulate the values and comment on the closeness of the probabilities obtained. Okay, if you want to comment, if you want to have a comment on the closeness, then I think you just need to have a sentence. A very simple sentence that tell you what does this one mean. Okay, what does this number mean? You can bold it. Okay, this is a number very important. Okay, so the comment is, I just do it here, but you maybe later you'll do it in your paper. Okay, see how you want to arrange this cell so that it looks nicer. Okay, it's your own way to design your own sheets. Okay, the comment is now this one tell you the average, right? The mean means the average. So the average, every time if you want to comment a mean, just like how you did in your exam, if I want you to calculate a mean and I ask you to comment, you just say that, oh, the average of blah 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 is what? Okay, you just write the full things. Just write the full meaning of this one. The average value of the difference of the two distribution, or you want to say more specifically, the difference of the differences between the binomial distribution and the Poisson approximation to the binomial distribution is, well, actually the screen is very small. You all can zoom in. You all know Zoom, you can zoom. Okay, Zoom can zoom. Okay, or YouTube also can zoom. I'm not sure YouTube can zoom. YouTube can zoom, right? Okay, is about this value. Okay, is roughly is about, or just say is 0.015 7. Maybe just give it that. Okay. You can add more accuracy lah. Okay. Depends on how you want to do. But this is just a short comment. You no need to copy exactly the same like me, but I mean, adjust a bit. Okay. Change some word. Okay. So this is the small comment. I think we already finished for the part C, right? Of course, you do that the same for all the other part. Actually I should do this first, then only I copy paste, then that will be easier. No need for me to now want to do one by one. But that is okay lah, because I'm not going to do it again. I will leave it for you to do on your own. Yes, average function, correct. Equal average, and then open bracket, close bracket, and then select all this one. Select all this one, baru close bracket lah. Can see the average formula. This one, right? Okay. Okay, next. What else? Okay, let's do one more. This one, I just copy and okay, I just copy this one. I mean, yeah, this one. Paste it here. I think I should have all the number in order to compare the value. Okay. Okay, never mind. So once again, you do for the same, the mean of the absolute one. You can paste here, but the value here, yeah, exactly the same, right? It's about this one. I just change this one, okay? So 0.037 0.371. 0.371. Okay. Yeah. Okay. So far so good. Now, of course, you do for the rest of the other two. Okay. Let's do. Okay, let's do together lah, because I want to show something to you. Okay, the values here, the absolute difference. Okay. So you do the same, right? Is it? I think we should just now do that first lah. So you no need to type one by one like this one. Okay. Copy paste. Copy paste here. Hey. Copy paste here, but there's a little bit things here. If you check the formula, because you change from n equal 10 to n equal 20, so the average also you need to change also. You need to start from this one, okay, or just like from 0.7 to 0.27, okay, or this 21 number, okay, and equal, okay, this one. You change yourself, this one you edit yourself, okay. 0.0082838. Okay, one more. One more. Okay, one. So you can do on your own. Go a bit faster to complete all the values here. Why the same value? Okay, what formula? Average. Hey, why? Oh, average. You see, sometimes your function name wrong, so we have a problem here. Okay. What happened? Okay. Okay. So, yeah, like this. Okay. Why I need to do complete all these four? Because in order to proceed to the next part, then you know what does it mean? Okay. So now all these four values, right, are very important because they tell you the differences is about the the difference okay, difference between the two value. What do you think? The closeness. Okay. What do you think the closeness is? Comment on the closeness of the probability obtained. You by now you can have a small conclusion already. If now you cannot see, it's okay. Wait, let me change this one. So this one's what? 0.0204, right? Okay. Never mind. That's okay. Okay. Now you already done four conditions, right? Four different cases, and you get a different value of this one. Okay. So now you can do a small analysis. Okay, which is okay, we do a small analysis here, which is when the n equal to what and the p equal to what. We want to discuss about the value of this one, the one that I highlight here, the mean of the absolute difference. If the difference is smaller, it's telling you the approximation is better or is worse. Which one do you think? If I want the approximation to be better, what do you think this number should be? Smaller better or what? Or bigger better? Because you're talking about differences. Okay? You don't want them to be differ too much. You want them to be close to each other. So the difference will be smaller, correct? So the smaller the value of this number, the highlighted number, is better your approximation. Am I right? Okay. So this is a small thing that you must make sure you know lah. Okay, so here you can change the value of your n and your p here. Okay, somehow I prefer n here, p here. Okay, no reason. Okay, so what you have done is when n equal to 10 and n equal to 20, and the p you have done is 0.3 and 0.6. Okay. Okay, now tabulate roughly the values here. The mean of the differences. You are now tabulating the mean of absolute difference. Okay, you can complete the whole sentence. Okay, now for n equal to 10, p equal to 0.3, you can go to this case and copy this value, Command C, and go to this analysis part. Okay, don't Control V because you would get what? They don't know which one you are referring to. Okay, they have no references. So you shouldn't copy paste. You shouldn't Control V, Control C. I mean Control C, Control V, but Control C. Go to here if you want to paste something. Remember, what do you do is you right click, okay, or you use two fingers to click. Then depends on your own this one. So you go to paste special. I think you will have a bar for paste special. Yes or no? Paste special, you only want the value. So you go to paste the values only. Paste value, then you would have this value. Okay. Actually, it will show up many values here. Okay. The formula bar here. So this is the value you want. Clear? And you do that for the same for all these four numbers here. Okay, let's do. This is here. So we can compare directly the values. Paste special value. Paste special to values only. Okay, just make it unbold. Okay, simple. Okay. Now, based on this one, what is the conclusion? What is the two conclusion you can say from here? What is the comment that you can say? The mean of the absolute difference. Okay. What you should say is, I make you small things here, okay, for you to compare. Now, you must compare two things, which is when the n change and when the p change. Okay. So what is the effect of the effect of n increases and when p increases? The effect of, or you want to do decrease, it's up to you. Okay, because that's the balik only. Okay, the effect of this one and to the mean of absolute difference become what? Okay, just move this one over here. Okay. Okay, the mean of the absolute difference, these are the values, right? Okay, so you want to say they are increases or decreases? Okay, increases or decreases? Yeah. So what do you think? Okay, this one is, well, n increases, so you see where you look down a column, correct? Because you look vertically, you look vertically down means that when n increases, what about the value of this? Increase or decrease? From 0.015 to 0.008, do you think increase or decrease? Of course. Now you compare vertically down this column also, 0.03 to 0.02 is also decreases. So the mean of the absolute value is decreasing or decreases. Okay, decreases, decreases, okay? Okay, we talk about the effect, okay? But I want you to make that in sentence, okay? Don't do like this. I just make in a table to summarize the things, okay? Now, what about P? Meaning that you compare horizontally, right? So when P increase, what is the effect on this one? Increase or decrease? From 0.015 to 0.03, okay? Increases. 0.008 to 0.02 increases as well. So the effect is increases. Okay, so what does it mean when the mean of absolute value increases? What about you? What you can say about the closeness of the two distribution? They are closer, or they are, what do we call the terbalik opposite word? Closer, they are what? Further, is it? Or what? What do we say the opposite word? Not that close. They become more far away. How do we say that? Further, is it? Further? Okay, closer, further, is it? Okay. So the closeness of the two values is now when the mean of the absolute difference decreases, means they are closer to each other, right? So this means closer. Okay. Now this one terbalik. Okay, this one, because the mean of the absolute difference is increases, so it's become further to each other, right? And last but not least, we can say about how good is the approximation. The approximation is better or is worse. So the approximation, or the how do you say that, effectiveness of the approximation, or you want to say how good is the approximation? Okay, so this one is better, right? Because closer, right? They are better. This one is worse. Okay, a simple, but you can change this one into two sentences first. Okay, or you want to start differently, you want to say when n decrease also can, when p decrease also can. Okay, so now I want to ask you a last question. In order to achieve a better approximation, you want to increase or decrease your n, and you want to increase or decrease your p. You want to do both things together. You want to have a big n or small n, big p or small p. Actually, they say comment on the result, right? Actually, I'm doing a little bit part of the part D already. Okay, you see, look at your instruction of your part D. They say by exploring at least 3 combination more. So all this combination you can choose from. You see, they actually give you the condition and more than 20. Okay, you can choose maybe 30, sorry, or maybe 50. And the p less than 0.3, you can choose maybe 0.2, 0.1, 0.05, who knows? Maybe smaller, 0.01. Okay, it's up to you. Okay, but at least 3 other combination. Okay, choose any 3 else. And later you want to make do one time comparison is also okay. For example, let's say, okay, for the part D, I want you all to do on your own because you can have your own choice, but I'm just going to show you one more only. Okay. Okay, so from what you can see here, of course, if you want to get a better approximation, your n should be big. Okay, increase the n, decrease the mean of the absolute difference, become closer, then it's better approximation. But if you want to get a better approximation here, as you can see here, you should decrease the p. You should make your p smaller, right? So the final words is, okay, good approximation when n is large and when p is small. Okay? Okay. So I'm just going to do one more for you, 50, and when p equal to maybe, actually I want to put a smaller one, so I just do like this. I put 0 point, just put 0.1 maybe. Okay, you can do for the rest of the, see which one you want to do. Okay, so later on I would get another value over here, right? Because n is bigger, p is smaller. This value you can tabulate a few. Okay, if you want to use this way, you can have any other way to analyze it, not necessarily like in this way, depends on you. Okay, so let's do one more case. So after we have discussed these more things here, so now n equal to 50, right? P equal to 0.1. Okay, let's investigate what about this one. Okay, now I'm just going to copy paste this. But let's change our n equal to 50 and p equal to 0.1. And all the things we're going to change, but that is not the end, because as I say, n change to 50, the first thing you need to do is also you need to change your x to up to 50 value. Okay, up to x equal to 50. So here, what you can do is copy and paste this one. Let's go down first. Okay, or maybe, can you see this one? I think it's it's quite like this, but I will tell you what you need to do. So you know, you make your eyes suffer. So drag until 50, right? 50, okay. Then this one you also put down, put just right below the 50. Okay. Now you do the 3 things all together for here. Okay. I know it's very small, but drag 1, 2, 3. Okay. Drag this 1, 2, 3 and all together. Do the same thing until this part. Until the 50 value. Okay. Now it would the mean absolute difference, I think you need to change because just now it only calculate up to first 20 value only. So now you can change the place. You can change the position. It's not 27, I think it's 57 here. So from D7 to D57, there are 50, actually 51 value here, and enter. That is the new mean that you obtain. You see, this value is very, very small, right? So I just copy my value and later I will put in my analysis here, paste special values. I'm just going to put here. As you can see, this value is much more smaller than all this, right? 0.001, right? Compared to 0.008. This one is the smallest among these four numbers, and this one is even smaller than this, right? Okay. So what else? Now we can go back here. Okay, of course, when you do one more case, which means that you also need to do the graph, okay? All the graph things. What else? The part C already done because all calculate this one, right? So you already done. But let's look at the graph. So if this is a good approximation, then the graph shouldn't different very much. As if I use my favorite graph here, line graph, then you can see, let me make it bigger. Then what you can see, they are very close to each other, right? Don't believe. Let's compare. Looks like you say, looks like no, here still got a big difference, right? Because we are looking, zoom out like a 50 value here. Or what you can do is, maybe you can, hey, what happened? Why I can't? Wait, what happened here? Why I can't shift? Okay, can. Okay, or you can, if you think this one is too long here because here you all these values are too small, you can also just investigate the first time value, see what happened here. Okay, if I'm going to do this, because if I want to have a direct comparison between the graph number one, so I'm going to see the first 10 values. Okay, first 10 values, compare with maybe this one. The approximation, is it better? Okay. So if you think that it is not better, it is not good enough, there's still a very big gap difference, then what should you do in order to make it perfect? Which value you need to change in order to make it more perfect? So I leave this as your own homework, right? So you can do it on your own. Investigate three more combination, right? Apart from these four. So just now I do one more for you. Maybe you can do some other better one. Okay? Okay, so okay, so that is the part D. Now, actually, there is one more small part which they want you to do. You see, you may compare their cumulative probability. Comment on the result of that. Okay, the comment I want you all to do on your own. Actually, I already give you many hints here. Okay, the comment just based on this one to tell more about this one. Okay, how you want to arrange your sentence. Okay, to compare the CDF, so I just do one and you do the same for the rest, okay? So I just do one only. I don't choose this one. I choose. Okay, we just go for this one, okay? We do for the first one and you will see. Okay, sorry. Why you keep going down? This one is lagging okay, somehow. Okay, never mind. Okay, now if we want to look at the CDF to compare the CDF value, we can also have all the values of the CDF and we can check the difference. We can compare the graph as well. Okay, so there's a lot of things that you can do, but I only do in one sheet. You can copy that things for the rest of the different case. Okay. Okay, so now let's calculate the PDF. Okay, then we can compare. Can you see here? I'm not sure what you are seeing. I'm not sure whether you can see clearly or not. Okay, I hope so. Okay, here if you are using phone, then it's really very difficult. Okay. Now, here I want to say the CDF. CDF. Okay, you just make your sentence on your own. CDF using binomial distribution. Okay, binomial distribution. Okay. Okay, I will leave using formula for your formula. There are two ways to calculate this also. Depends on your own thing, but I think I will teach you both because both are useful, not in just in this case, but maybe in some day later in your workplace also. Okay, what you can do is, if you want to calculate the CDF, let's say for using, okay, now one is binomial, right? I just copy the title. CDF using binomial. One more is CDF using Poisson approximation. Okay. I teach you two way as well. Now, the way one, I'm going to put it here, the blue color one. Okay, but this one, I just show only lah, but you make sure that you do the things, the letter thing. Okay. Now, if one way to do is, if you want to calculate the CDF or the cumulative something related to cumulative, then this is one of the way that you can do if you want to iterate it. Which means, first, the first row CDF, of course, or the cumulative frequency, so something like that, is of course you take the first value, right? So you just press equal to this one, B7, and return. Okay. Now, starting from the second one is a little bit different because cumulative idea is you taking the previous cumulative plus the new value. So D7 is going up, the previous cumulative plus the new probability plus this one. And you press equal. That is a new value here. Okay. Then you are going to repeat the process for this one. Okay, I show you one more time. I show you one more time so that you understand what you are doing. If you want to get the third number, is it the same that you press equal and you get the previous cumulative plus the current probability, previous CDF plus this PDF. Okay, and you press equal, that will give this. Okay, now you want to repeat the process for this and you just drag until your last value. Okay, make sure that your last value here is also 1, right? As we expect. Okay, CDF, the last value must be 1 for binomial, of course. But for the Poisson one, if you do the same thing like just now, so the first one is this, the second one is previous plus current. Okay, and you do the same, starting from the second, you can really do the same, just drag until the last one. As we see that this one is actually the sum of all these values, correct? 0.99970 something. Okay. I don't know. Maybe you can see this better. Wait, let me adjust something. Okay. Okay, so can you, okay? I think this one, your vision is better. Okay, I just close the chat box first. You anything, I will open it. Okay, then I think that's better for you to see. Okay, what else? Okay, okay, so now this one is the things. Okay, now you want to get a graph for it, right? If you want to talk about if you want to illustrate it graphically, then what you can do is Of course, you can do both together because you want to compare, right? So you can compare the graph. Now for this one, which one is better? Do you think this one is good? Now, for this one, if just now you choose the bar, that is okay. But for this one, I think this is better, right? A line graph is normally the plot of the PDF. So for PDF, for CDF, you just choose the line chart. Okay, you choose the line chart as actually best represent the properties here. So you can see how close they are, even though this one is not very close. Actually, it's already close, but as compared to the other, you will see it is not that close actually. Okay. All right, as I said just now, this is just the first way only, okay? Sorry, okay, what you can do is you can get the absolute difference here, but I'm not going to show you absolute difference. You can do this one. You don't do is also fine. I don't think this is very necessary, but you can compare this, okay? But what can you say? If you want to do more job, okay? If you want to have more things to discuss, you can do this on your own, all right? Okay. I go back to this one. As I say, we have a second way to calculate all these things, right? Okay, I'm going to show you. Okay, I think today we are not going to cover the Poisson normal approximate Poisson. That one will be on the second day, okay? So yeah, I explain a little bit longer than I expect. Okay, never mind. Okay, now for this one, if you use the second way is actually I want to use the Excel function, especially for the statistic distribution only. Okay. Just now that one, this concept, this Excel technique you can use for the rest of your life, but for especially CDF for the binomial and the Poisson, you just need to do a very simple thing. Okay. From here, you can copy and paste the value. Okay, you copy and paste the first two number here, first two row here. Okay, you place it here. Okay, and then okay, now you see that? Okay, now how to get the CDF from here? Very simple. Okay, why? Because I want the formula here. Actually, I'm not wanting this one, the value, but I want the formula here because I just need to do one thing in order to switch the PDF to CDF, which is the false here. I just need to change to true because you see, if you put true, then you can get the CDF value, the cumulative distribution function. So TRUE true, press equal, or even though this one is the same number, but when you press and drag it down, you would get, again, sorry. Let us check where is the things here. Okay, I'm so sorry that the D7 is not actually D7. Change this one also. The number of your success should be go back to the 0 as well. Okay, go back to the 0. Okay, one more time, you get this one, right? So it means here you start from the number of success is A7. I mean, the 0, add your X here, okay? And then all the other thing is the same, except for the final one, you change from false to true. Okay, and you do that for the same, then you will get exactly like just now. Just a different way to obtain the same things. Okay, so today you learn two things: how to get the same value using function formula and also using the Excel. For CDF, you also learn two ways to get. Okay, now this one as well. You just change this one to true. This one is not D7, it's actually this one also. Okay, then you drag, you would get 0.0999, 0.9997. Okay, same thing here. There's a different way to obtain. Okay, if you want me to write out the formula, I'm just going to put this one. change a little bit here. X less equal than X. That is actually a wait. Small x here, big X, big P. This is equal to this formula, but just change the false to true. Okay. The formula changed like this only. Okay, same goes to this one. Mm. Okay. Okay, like this. Okay. So you have a two-way here. So I already show the formulas here. Okay. You can use this way to calculate. Okay. So far so good. We have actually covered part D already, right? Finished part D already, huh? So compare the cumulative probabilities. You can comment about the probability distribution. How does this change of the N and P affect your graph? Both PMF and PDF graph. Okay. So now, last but not least, I'm going to end the today lesson here already. The condition is very simple only. I'm just going to put it here. So what is the part E? Discuss the condition on the Poisson approximation, right? The condition. So what do you think is the condition? Why you have this symbol? E. Okay. The condition is, so what do you think? Okay, let me tell you, condition, you are just going to tell the effect, the values need to be large or small only, okay? If you want to be specific, telling a specific value of n, where you, what is the minimum n you need to reach, like how you did in your exam, okay? NP greater than 5, NQ greater than 5, that one, okay? So you can give a specific, that one is also okay. But I'm just going to tell you, like just now, n need to be large, right? N need to be sufficiently large, P need to be sufficiently small. Okay? And I just write simple. It depends on your own on smart way to write. N need to be large and P need to be small. Because the condition is like this. Okay? After we investigate. Okay? Now, if you search what is the condition of blah, 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 online, you would get a lot of answer. You will get a lot of answer, right? I'm sure that you all would see lah, what n greater equal to 20 lah, n greater equal to sometimes 50 lah, or np less than 5 lah, NQ less than 5 lah. Okay, in fact that actually what I put in your notes there, I also put this, right? If you check that, but that one is before I look at your assignment here. So after I look at it, actually I was thinking, yeah, you just need to tell in general what is the changes, okay, of your N and P that can affect your how good is your approximation. So then you can tell the condition. What is the condition in order for you to have a good approximation, right? Okay, then you say sufficiently large and P need to be small. So how much you can tell? Okay, if you want to be specific, you can set the value of N and the P. For example, you say N at least 50 lah. That is one of the possible way. Or maybe P is very small, then P less than 0.1 maybe. Okay, but that is up to you. Okay, but this one I don't think is needed. All right, so that is all for task 1. Any question before we end today task? Okay, task 2 we are going to discuss on the other day. I would let you know, maybe this weekend or maybe I don't hope to use 2 weeks to discuss this one, so I hope to settle in this week. So most probably I'm going to do it in weekend. Okay, if you're not able to join, you just join the recording lah, watch the recording. I think that's better also. I think many of you watch the recording because you all can't follow, right? Okay, you can share to your friends for this task 1 later in the YouTube video. And okay, task 2 is only for you, so don't share the task 2 lah. Okay. So that's all only. Okay, see you and goodbye. Good night.